Good day, everyone. This is Arvin Alonso demonstrating to you IT application tools. In this video presentation, I will demonstrate how to make use of spreadsheet, particularly Microsoft Excel, for some statistical analysis. And in this video presentation, my focus is on measures of dispersion. So let me give you an overview of the measures of dispersion. We have to take note that the measures of central tendency do not indicate the extent of dispersion or variability in a distribution. And dispersion or variability will provide us one more step in increasing our understanding of the pattern of the data we have. Take note, a high degree of uniformity, for example, low degree of dispersion, is a desirable quality. We have an example here. If in a business there is a high degree of variability in the raw material, then it could not find mass production economically. So what is measures of dispersion? Before that, what is dispersion? It also means spread or variation. And dispersion, as defined by many authors, have the following definitions. It is the measure of the variation of the items by Bowley. It is the degree of the scatter or variation of the variable about a central value. It also is the measurement of the scatterness of the mass of figures in a series about an average. And dispersion is also called averages of the second order. Dispersion measures the extent to which the items vary from central value. Take note that an average is more meaningful when it is examined in the light of dispersion. Let me give you a situation here. For example, the average income of employees of companies A, B, and C are the following: 12,000 for company A, 15,000 for B, and 16,000 for company C. And in this situation, we cannot immediately say that company C gives the higher salary basing from the average income alone. Why? Because company C may have higher dispersion than company A or company B. Let us have another situation. Assuming that companies A, B, and C have the following employees and each of them receive the following salaries. And if you try to look at it, they have an average or mean salary of 12,000. But the question is, do you think that these three companies are the same in giving salaries? On the average, it may be, but when we look into the measures of dispersion, it will have a different story. Now, what are the basic purposes of measures of variation? First, it points out as to how far an average is representative of the mass. Second, it determines nature and cause of variation in order to control the variation itself. And third, it enables a comparison to be made of two or more series of or with regards to their variability. And lastly, there are many powerful tools in statistics such as correlation analysis, testing of hypotheses, analysis of variance, statistical quality control, regression analysis, which is normally based on measures of variation. There are properties of good dispersion. We have simple to understand, easy to communicate or compute, I should say, rigidly defined, based on each and every item of the distribution, amenable to further algebraic treatment, have sampling stability, and extreme items should not unduly affect it. And in these measures of dispersion, we will discuss the following. particularly in using Microsoft Excel. Range, interquartile range or the quartile deviation, the mean deviation, standard deviation and variance, the z-score or standard score, and the Lorenz curve. Let's get started. For our demonstration, we will be using this sample dataset, assuming that we have 20 employees with their corresponding age. Now, for a review, we have the average function to get the mean, average, and then specify the range of data values. So in this situation, we have B2 colon B21. The colon specifies the range. So in this situation, we get the values from B2 to B21. Now, for the range, first we get the maximum value or the highest value and the minimum or lowest value. In a spreadsheet software, we have a function max to get the highest value. So max B2 to B21. This function will get or determine the highest value in the dataset. So in our example, we have 64 as the highest value. And for the mean value, we can have mean B2 to B21. Since we have already the maximum and minimum value, we can now compute the range, and that is getting the value of maximum value minus the minimum value, which is in F4. So F3 minus F4. Or we can combine directly the max and mean value to compute the range. For example, we can have max B2 to B21 minus mean B2 to B21. By the way, whenever you change any of the dataset values, for example, I change this one into 70, automatic, the values where the formulas are will also change. So in this situation, the maximum value is now 70, and so we have a range of 50. Okay? But let me just undo the enter data. For the coefficient of range, the coefficient of range can be computed as L minus S, or maximum value minus minimum value, all over L plus S, or maximum plus minimum value. So, the coefficient of range, therefore, is we have F3 minus F4. But let me put an open and close parenthesis here, divided by F3 plus F4. So our coefficient of range is 0.52. Now, assuming that we would like to round off these values to 2 or 3 decimal places, we can make use of this. Or we can have the function round off to be included in the formula. Round, open parenthesis. So take note that there's a formula to get the coefficient of range, and then we specify the number of decimal places. For example, 2. So we have 0.52 as the coefficient of range. We now proceed to semi-interquartile range or quartile deviation. And part of it, we will also discuss interquartile range. So first, we have to get the values of quartile 1, 2, or 3. In this case, we can only get quartile 1 and quartile 3. And the function that we can use to get the quartile 1 is equals quartile. You notice that there are three functions available here for quartile. We can use the old one, quartile, and then the array. The array is from B2 to B21. And then what's the quartile value? You notice here, 0 would mean getting the minimum value. And in that case, we can have 20 as the minimum value if we place 0 here. So since we are getting quartile 1, we specify 1 here as the quartile value. So for quartile 1, we have 31.75. For quartile 2, the same function, we get the range, comma, we specify 2. You notice that quartile 2 is also equal to median. So we have 40.5. So we have a median function actually. Let us just see. Median of B2 to B21. So they are the same in value. And quartile 3 is quartile function, and then the array B2 to B21, comma, 3. And if you would like to get the highest value using quartile, we can specify also the quartile as 4 if we would like to get the highest value. Okay, so for quartile 3, we use 3. Now, what will be the interquartile range? The interquartile range is quartile 3 minus quartile 1. And that is F11, F9 I should say, minus F7. Quartile 3 minus quartile 1. So to get the quartile deviation, we have a formula F9, which is the quartile value 3, the quartile 3 value I should say, minus F7, which is the value of quartile 1, divided by 2. But take note that we have to specify or type the close and open parentheses. So F9 minus F7 divided by 2. So our quartile deviation is 11.75. To get the coefficient of quartile deviation, the formula will be quartile 3 minus quartile 1 all over quartile 3 plus quartile 1. So in this situation, we have F9 minus F7 all over F9 plus F7. So we have coefficient of quartile deviation of 0.2. Again, if you would like to round this off to 2 decimal places, you can use the round function, or we can have this one. We now proceed to mean deviation. mean deviation can be computed using AVDEF as a function. But if you would like to see or show the, the deviation of each data value from the mean, then we can have another column for that. By the way, we get the absolute value of the deviation from x. So, in this column, we can have B2 minus the average value, that is F2. But let us convert F2 to become an absolute reference. So let me press function F4 here to make F2 as an absolute reference. Okay? But let us add another function into our formula, and that is abs function. Abs function will get the absolute value, meaning it disregards the sign, especially negative sign. So we have 22.5. Then we just click and drag this one up to the last data set or data value. So these are the absolute value of the deviation from x. So to get the mean deviation using the values in column C, we can have sum of C2 to C21 all over the number of data values, or our n. And in this case, we have 20. So the mean deviation is 11.85. Now, to get the mean deviation using a function, we have AVDEF and then B2 to B21 for the data values. So you notice that the two formulas will give the same value. So that's for mean deviation. We now proceed to standard deviation and variance. In getting the standard deviation and variance, we can also make use of a function. But this time that we will present two functions, one for getting the standard deviation for a population and for a sample. The same as true with variance. We have a function for getting the variance of a population and a sample. So the function for this is stdev. Since we're going to get the standard deviation of a population, we make use of stdev.p. And then the range. So B2 to B21. So we have standard deviation of 13.82. To get the standard deviation of a sample, assuming that this data values is from a sample, we have stdev.s and then the range B2 to B21. To get the variance, we have variance function var.p for a population, and then the range of data values B2 to B21. And the variance for a sample is var.s B2 to B21. So that is getting the standard deviation and variance of a population. In case we would like to get the standard deviation and population coming from the table using the deviations from x, the next thing that we need to have is two have a column for the x or deviation from x squared. So we need to square the value of this, and that is C2 caret symbol 2 to square. Okay, get the sum of all of these. So I'll just click and drag, and then I will get the sum of all the squares of the deviation. So that is D2 to D21. So to get the standard deviation, we can have SQRT of D22 over 20. So we have the same value. Okay, over 20 because we are getting the population. But if this is a sample data value, then our formula would be D22 square root SQRT function of D22 all over 19, that is n minus 1. So we have 14.18. And for the variance, we have the sum D22 all over 20. Okay, while for the sample, D22 all over 19, 20 minus 1. So it's the same. So that's for standard deviation and variance. We now proceed to getting the standard score or Z score. So in this case, we need to insert, have another column for the Z score. And for the Z score, we need the value of the mean deviation and mean or average. So the function to get the Z score is we have standardized, open parentheses, the value, which is B2, comma, what's the mean? Mean is 41.45, or we get it from G2. So G2, we press F4 to make it as absolute reference, comma, and then the standard deviation. We will be using the value of sample. So here we have G16 or 15, I should say, and then just the same, we make it as absolute reference, so we press function key F4, close parentheses. So the z-score of the first data set, or data I should say, is 1.5. Let us just click and drag this one up to the last value. Now we proceed to Lorenz curve. The Lorenz curve is normally used to show inequality of income or wealth or in other systems. So for example, we have this data set. We have the percent of population and then their corresponding percent of salary. And first, we need to get the sum of the salaries. So the function is sum B2 to BF12, after which we get the uh, percent of income based from the total salary. So for this, we have the formula B3 over B13, and that is the sum. So we make an absolute reference for B13 times 100%. So we have this one. Even if you don't have this one, you can just click and drag this one to get the percent of income. The next column is actually to get the cumulative percent of the income. So first is we have D2 plus C3. D2 is the first 10% income plus C3 is the value prior to this cell or value. So we have 5.19. Then we just click and drag this one to get the cumulative percent of income. Okay. Now we proceed to preparing the Lorenz curve. To get the Lorenz curve, let me copy this first and I'll paste it here, for example. Paste, right click, paste values. I'll copy it again and paste it. So we have the percent population. And then in this area, assuming that we have 0 as the values, assuming that and then we get the cumulative percent income for the next column. Okay, then highlight this one, insert charts, and we can make use of this or this one. So we will use this one. So we now have the Lorenz curve. Okay, so here it shows that the straight line, diagonal straight line, is the percent of population from 10, 20, 30, 40 to 100%. The curve here shows the cumulative percent of income based on percent of population. Now, we can modify this graph. For example, uh, modifying the x-axis value, the interval from 0 to 100. And then the same as true with this one, from 0 to 100. So close this one. Now you have the perfect curve for the Lorenz curve, and then you can change the chart title if you want to. So that's all for the Lorenz curve. I hope you learned something new in this presentation of the measures of dispersion in spreadsheet. God bless everyone.